Okay, so for the sake of recording, I'm just going to repeat myself. Today we're going to try and crash course 5.1 and 5.2, largely because you already know how to draw the sine and cos curves. If this is the first time, I hope that you'll be able to keep up. I'm also going to, looking at the second page, do a tan curve, which is sine over cos. So instead of actually doing every sine over cos as a division, we'll do the divisions first, plot out a full 360-degree range or domain, and then we'll, see a pattern hopefully and just repeat. Here we go. Please note that I intentionally made the angles small in, I guess, what's the word I'm looking for? I guess the distance between the two are small, but then after a certain point, I'm just jumping and I'm doing it every pi over 4, or in other words, every 45 degrees. Okay, so sine. If you're doing this correctly, you should get 0. And then at 90 degrees, or pi over 2, you get a 1. Here is a root 2 over 2. But if you're doing that as a fraction, it's a little hard to graph. So take your calculator, if you're watching this at home too. I'm going to take my calculator and just do the division, just because I don't know how to graph root 2 over 2. Root 2 divided by 2, and that is 0.707. So for the sake of my graph, I'm going to say about 0.7. Like, whether I mark 0.7 or I mark 0.71, I don't think you'll be able to tell. So I'm going to say approximately 0.7. Okay? Pi over 6 is exactly half, which is 0.5. And pi over 3 is root 3 divided by 2. Which is root 3 divided by 2. 0.866, so 0.87 approximately. Okay? And with these 5 numbers, you should be able to fill the rest. 0, 1, and then at 180 degrees, I'm back at 0. And then at 270 degrees, I'm at -1. And back at 360 degrees, I'm at 0. I'm going to graph it. 0, 0. Pi over 2 is 1. Pi back at 0. 3 pi over 2 is -1. And back at 2. Okay. Let's see. 3 pi over 4, sine 3 pi over 4 using cast rule, it's the same as pi over 4. 5 pi over 4 using cast rule is negative pi over 4. And this would be, again, negative pi over 4. I have 0.5, 0.7, 0.866, 0.87. And then it goes down to here. Oops, it goes down to here. All right. And back to here. And then it goes to here. And then back to there. So again, I'm jumping all over the place, but I'm assuming that from here, these 5 points, you are able to reproduce that everywhere else on the graph. Okay, so do so. Please finish this off and also go to the left side. How about I use a different color pen to show? And for the sake of practice, please try to draw the nicest semicircle you possibly can. Even on this little art pad, it's taking me a couple of tries. and finish off with a little arrow. If you're able to do so, please, quote unquote, extrapolate, do the exact same cycle or curve on the left side. I am going to mimic the points that we calculated by -1, then a 0, then a +1, then a 0. And then I'm not even going to dot myself. I'm just going to try to draw the nicest semicircles I can. And if it looks decent, feel proud, okay? It's not easy to draw this freehand, at least right now. Yes?
For like a test, are you going to mark us on like drawing skills, or is it like genuinely the right shape?
I will mark you as incorrect if you do this.
If it's like you attempted to draw circles, like,
If I see that an attempt was made, I think I'll be fine. Make it a good attempt though. Through all of your practice, every single time you draw a sketch, I'm hoping you'll get closer and closer to a perfect circle. All right? Right underneath, there's a sentence that says, highlight one cycle, state the domain, range, period, and amplitude, and the transversal or mid-axis. Why do I get you to do this? It's going to be useful on Monday. Domain, one cycle from 0 to 2 pi is one cycle, right? Of course, you could do this if you wanted to. That's technically one cycle as well. But just by convention, I would like you to start from 0 to 2 pi, because that's where a untransformed sine function begins. State the domain. What is the domain? Well, anything really. State the range. From what to what? Yeah. I'd like you to think back to grade 11. All of it should be coming back. Period. How about we use the physics symbol? Period. Okay, never mind. Forget period. How long is one wavelength? I think some people might be confused with physics. Period, you associate with time, I get it. How long is one wavelength? Or one cycle? 2 pi, good. No, yeah. So wavelength, it's, I'll say, okay. Amplitude. Please be advised, amplitude is not the range. That's the amplitude. And going back to your physics lessons. Transversal. So the mid-axis is something that we will use to our advantage later on. The transversal is right here. What is the line that the curve always returns to? The mid-axis, right in between. And that would be the equation of? Yes. Okay, that is the mid-axis. The proper term is transversal, but I don't think any textbook even uses that. Okay, so with that said, I'm going to go through cosine very fast because I want to get to tangent. And then I'm going to use this graph for secant, cosecant, and stuff, okay? So if you've done what I've done here, that's fine. But you just know that I am going to be drawing over this a little bit. So if you want to erase this, you can, but I mean, just warning you, okay? Let's do it. Cosine starts from 1, goes to 0, gets to negative 1 goes to positive. Oh, it goes back to 0 and then to positive 1. This is still root 2 over 2, and so that would be approximately 0.7. And then this goes to negative 0.7. It comes up to negative 0.7, goes up to 0.7 and down. And just to be accurate, pi over 6 would be approximately 0.0886, so about approximately 0.8. Is that what we wrote up there? 87, sorry. I thought it was 886. Or is it 866? 866. That's why it was. Bad short-term memory. And then 0.5. Graphing this, my cosine function starts from a max, goes to a 0, goes to a negative 1, back to 0 and 1. And with those 5 points, you'd be tempted to just draw a big V. That's not true, because you know that it goes to about 0.87, 0.7, 0.5. Then it goes to 0.7, negative 0.7, positive 0.7. Once again, please try to draw the nicest curve possible with these semis. Oof, it's a little rough. Okay, and using that, I know it goes to 0, negative 1, 0, positive 1. Trying to draw the best semicircle I can. Oof. Rough. Bam. 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 And of course, the arrows continue. So there's your even function. I am not going to go to lengths to describe it other than just highlight one of the cycles, okay? And so we've got domain. I guess I'll do it. Domain. It's still negative infinity to positive infinity. Range goes to from negative 1 to 1, including negative 1 and including positive 1. Period. It's still 2 pi because it repeats. Amplitude, it's still 1, an absolute value of 1, right? Or maybe I should do an absolute value because it could be plus or minus 1, right? Or maybe amplitude is that. And transversal is y equals 0. Okay. Tangent. I'm going to ask everyone to use the 2 charts above you and divide. So 0 divided by 1, 0 point divided by 0.87, 0.7 divided by 0.7, 0.87 divided by 0.5, 1 divided by 0, and fill it in. Why not start with the 45 degrees? So 0 divided by 1 is a 0, right? 0.7 divided by 0.7 is 1. 1 divided by 0 is undefined. And then pi, then it's here. Undefined. 3 pi over 4. 0.7 divided by negative 0.7, negative 1. And then we have 0. And then we have 1. And then we have undefined. And then we have negative 1. And then we have 0. Is that right? Yeah. Okay. So you could fill this in, but I'm actually going to draw these points that we've identified every 45 degrees because you might see something interesting. At 0, I have 0. At pi over 4, I have 1. At pi over 2, it's an asymptote. At, let's see, 3 pi over, oh, wait, at pi over 2, at 3 pi over 4, it's a negative 1. At pi, it's a 0. At pi, 5 pi over 4, it's a positive 1. And then 3 pi over 2 is another asymptote. And then I have a negative 1 again, and then a 0. What do you expect to be here? Dun, 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 dun. That's right. So dun, dun, line, dun, 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 line, dun, 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 line, dun, dun, dun. It keeps on repeating. Why? Because sine and cosine keep on repeating like that. So with that same pattern, I'm going to go reverse. Dun, 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 line. Dun, 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 line. And dun, dun, dun. I hope nobody watches this video. Please no. My next video, I'll be singing a song. Okay. Oh my gosh, please no. It's so embarrassing as it is. Anyways, okay. So here's the thing. If we were to leave it at that, you would be tempted to draw a straight line because it looks like a nice straight line. But remember, it's actually a vertical asymptote. So it's going to curve out at some point. How does it curve out? Well, it'd be nice if we had a little bit more clues over here. Pi over 6. So 0.5 divided by 0.87. Hallie, could you do that? What did it become?
0.57.
0.5 divided by, is that right? 0.57 to confirm. Oops. Okay. And reverse 0.87 divided by 0.5. It's approximately, remember approx. And approx. Because if I did fractions, this would be equal to what? 1 over root 3, right? And the other one would be root 3 over 1. We've got approximately 1/4. So, okay. So pi over 6, which is very close to this dotted line, is approximately 0.57, like 0.6. It's right here. And a little piece right there, very close to that dotted line, is 1.14. I know it looks a little bit weird, but... Oh, is that right? Oh shoot, my calculator, I was wondering because the number didn't work out with the shape. 1.7, that's my bad. 1.74. I need it to be higher, 1.74 around here. That makes more sense. Long story short, it's a little bit slow to pick up, but once it gets past the point, the point of pi over 4, 1, it shoots up. It looks something like this. Sort of like a cubic. And if this point looks like that, you can bet it's going to repeat again and again. Doesn't that look cool? Either cool or trippy, depending on how you approach it, but that's a tan function. And again, if your grade 11 teacher forced you to do it, great. Are you ready? At this point, I recommend you have this, your front page ready as you look through the last page. Get what I'm saying? I would like you to flip the pages so that you have page 3 in front of you, but you have page 1 available too. Because every single value you have in your chart, I want you to take it and put it 1 divided by that number. Yep. A cycle? Oh, for this, 1 period or 1 cycle would be that. So yes, well, I suppose you can argue that 1 cycle is also from 0 to 1 pi, and that's fine. All you need to know is the wavelength or the distance of 1 cycle is a single pi, not 2 pi.
How would you write the asymptote to
The domain?
also
Right. You know what? Thank you for reminding me. So 1 cycle is right there. State the domain. The domain is still, so in this case, I am going to write it out as a set notation. Okay? X belongs to R, such that, what's it? X, such that F belongs to R, and X cannot equal pi over 2 or any multiples of that, of pi. Or pi n, where n belongs to integers. Does that make sense? X cannot be pi over 2, but if I add a single pi, it's 3 pi over 2. It can't be 3 pi over 2 either. If I subtract a pi, it'll be negative pi over 2. It can't be negative pi over 2 either. Okay? This represents, it could be a pi, it could be 2 pi, it could be 3 pi, it could be 4 pi, it could be 5 pi, it could also be 0. It could be negative 1 pi, it could be negative 2 pi, so on and so forth. It will cover every single multiple of pi over 2. Okay, in that sense. And the period, well, sorry, we got the period here, so it's 1 pi long. For the range, it's anything. Y belongs to any real number. Okay, while you're doing that, I'm gonna work through this. 1 divided by 0, undefined. Let's see, 1 divided by 0.7. That's the same as root 2. 1.4. This would be 2 over 1. So that's equal to 2. This would be 2 over root 3. So that is 1.15. And then 1 divided by 1 is a 1. Okay. This is, once again, 1.41. And pi would be undefined. We go down to negative 1.41. That would be negative. Oh, wait. Right? Yeah. Negative 1, negative 1.41, and then undefined. Please flip back and forth between page 1 and page 3, and notice that every time you see a 0 for sine, you get an undefined for cosecant, which should make sense because now it's a denominator. What does that look like on the graph? You ready? Oh, some people are still copying. If you're ready, I'd like you to first, anytime you see a 0 for sine of x, go ahead and draw a faint vertical asymptote on this graph. And for me, I am going to use a different color. How about I use green? And let's see what I can do without getting too messy. No, I will use pink. Fuchsia. Does that show up?
Yeah.
I don't like it though. How about I make it a thicker thing and opacity of it. So every time I see an x-intercept, when I do the reciprocal, it becomes the asymptote. And it shouldn't be too difficult to understand that because of our training with polynomials and rational functions. Next. Whew. You ready? 3 pi. Okay. Pi over 4. 1.4. And then 1. So undefined, 1.4, 1, 1.4, undefined. Undefined, 1.4, 1, 1.4, and undefined. It looks like this. Same thing here. Negative 1.4, 1, 1.4, and undefined. A cosecant curve looks like that. Once again, undefined, 1.4, 1, 1.4, and undefined. It's going to look like this. And undefined, negative 1.4, negative 1, negative 1.4, and undefined. A secant curve looks a little wild. And for the sake of clarity, just to show that you are doing it right, there it is. Trippy. That's okay. Will you ever use this graph? Very rarely would you ever see an application of this over sine. People prefer the sine and dividing by sine rather than multiplying with cosecant. But anyways, it is a good idea to understand that it exists and this is what it looks like. If that's what it looks like for sine, I'm thinking you can extrapolate and just apply the same idea to cosine, because cosine is the exact same thing, but we've shifted it to the left by, or to the right, to the left by 90 degrees. Here, look. Without even doing the chart, what can you tell me about these x-intercepts? They will become, that's right. And my goal is that you don't have to consult a chart, but you can look at a sine or cosine curve, because you've done it so often, and sort of figure it out on the spot. Here's how I do it. The maximum here of 1, the crest, so to speak. The y value is 1. What is 1 divided by 1? 1. What is -1 divided by 1? Or 1 divided by -1? Positive, 1 divided by +1? 1 divided by -1? 1 divided by +1? So those points don't change. But right at pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, blah, 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 you have 0.7. 1 divided by 0.7 gives you about 1.4. 1 and 1.4. A negative 0.7 will give you a negative 1.4. A negative 1.4. And if you're even more lazy than that, knowing where your point is and knowing where the asymptotes are, you can just draw that one dot and draw a curve afterwards. I'm not going to stop you. There is your secant curve. Any questions? Yep.
Would it be the same for cosine?
That's it. Yeah. This is cosine. This is cosine and secant. That is sine with cosecant.
Oh, yeah, I thought that was the same.
So let me draw a little arrow with pink saying that is cosecant x. Okay. And the curve down here, that is secant x. Now, the final one, tangent. Tangent can be a little trippy too, but I am simply, instead of filling in the chart, which we can do after, or I will do and I'll put it up for you, let's just divide 1 by the numbers that we see. First, where are your x-intercepts? Right here. They will become vertical asymptotes. If you don't want to draw, you just want to watch because it's going to get really messy. By all means, just watch first. Okay, next. An undefined value is because it was 1 over 0. If you do the reciprocal, it becomes 0 over 1. So this point is actually where the blue vertical asymptotes were, that becomes a x-intercept. Next, 1 divided by 1 is a 1. And 1 divided by -1 is -1. 1 divided by 1 is 1. 1 divided by a -1 is -1. Look at where these pink dots are, if you can see it on the screen. If I connect the pink dots and follow the same pattern as I would for these, so 1 divided by this would be 0 point something. 1 divided by 1 divided by 0 point something would be something much larger. It'll be something here. And then this 1 divided by that number would be something here. So it would look like these are terms. Sort of look familiar? Which makes sense because it's now cosine over sine. So the directions, the ratios, all of it is simply flipped. It's going in the reverse. Yes. Go for it. I'll say this. Unless things change, I will say that I won't ask you to transform cotangent or whatnot and do some complex things. However, you should be familiar with it and you should be able to visualize or answer questions based on it. We'll see some similar or familiar questions as we move forward, or example questions of what I mean by that. But your task essentially for today or for the weekend is review what you remember from grade 11 and very quickly be able to pull out or derive the sine or secant and cosecant graphs just from looking at sine and cosine. It shouldn't be too difficult as long as you are not memorizing, you're sort of looking at it conceptually, in my opinion. But approach it whatever way you feel comfortable. And that's it. Any questions about how they look or where they came from, where these numbers came from? I will take a moment to fill out the very last chart in case you want it for your notes at some point in the future. And we'll call it, and I'll put it on Brightspace. Okay? I'll call it a day.